Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so for today's session, I would like to continue stiffness method. Okay, we are going to analyze frame. So I actually have prepared past year's exam paper December 2015 to be discussed. Okay, to be discussed tonight. Okay, so this is the diagram, frame diagram. Okay, so always remember that in stiffness matrix method, most important thing is the degree of freedom. Degree of freedom. So we have three types. Okay, three type of structure we analyze using stiffness matrix method. Okay, we start with truss analysis, where truss has 2 degree of freedom in X and Y component. X and Y component, and then beam analysis. In beam analysis, we have 2 degree of freedom in Y and Z component, because in X component in beam representing horizontal displacement or horizontal reaction will be neglected. So we only count Y and Z component in beam. However, in frame analysis, we have to count 3 degree of freedom, per node in X, Y, and Z component. X, Y, and Z component means that to establish element stiffness matrices, okay, so we have 6 by 6 matrix for K1, K2, K3, we have 6 by 6 matrix. The procedure will be the same. We will start with the matrix for the stiffness matrix for element, and then we will combine to have structure stiffness matrix. For element stiffness matrix, we will use formula given in appendix, and then we have to combine to get the structure stiffness matrix. After that, we have to apply the force displacement equation, force displacement principle, which is stiffness equation, in order to calculate unknown displacement. In frame, we have to consider three component, X, Y, and Z component. And after that, after we have determined unknown displacement, we will continue to calculate unknown reaction at the support. So basically, procedure for all type of structure, including truss, beam, and frame, are actually the same, except degree of freedom. So this is the frame. This has 1, 2, 3, three element. So numbering in this diagram. So this diagram is labeling conventionally. We label A, B, C, D. Okay, not in numbering 1, 2, 3, 4, doesn't matter. Okay, most important thing, we know that members and element are the same thing. So from this, we know that we have 3 members or 3 element. 3 members and 3 element. We use numbering because stiffness matrix method is actually the method used in structural engineering software. So to analyze huge structure, so that's why we use numbering. However, in analysis, we can label A, B, C, or 1, 2, 3, doesn't matter. So by looking at this diagram, we have 3 element. We have element or member BD. We have member AD. We have member CD. We can call as member 1, member 2, member 3. Okay, we have 4 nodes, A, B, C, D. Join or nodes is the same thing. Okay, so frame has frame, because the formula in frame, the formula to calculate element stiffness matrix in frame, in the formula we can find Cx and Cy, or lambda x and lambda y. So To calculate Cx and Cy means we have to have coordinate. We have to have coordinate. In beam analysis, from the formula, there is no need for us to calculate Cx and Cy, because the formula, the formula to calculate element stiffness matrix in beam will be depending only, will be depending to length of the member only. Okay, that is why in beam we don't need to label the coordinate. Okay, and beam has local have same local and global coordinate system. In truss, under the formula of truss to calculate element stiffness matrix, okay, there are Cx and Cy. So whenever there are Cx and Cy in the formula, means that we have to put coordinate. We have to put coordinate because we will calculate Cx and Cy based on coordinate. And when and another thing is, when we have to calculate Cx and Cy, we have to put the arrow. The arrow is very important in order for us to identify which node will be the near end node, which node will be far end node. Near and far end, we have to be able to identify from the arrow. Anyway, arrow we can put in any direction that we like. Okay, so it look like that truss and beam, when we combine the effect, because in truss we have AE, axial effect. In beam, okay, there are what we call as bending effect. EI is bending effect. So in frame, there are combination of EA and EI in one formula. Anyway, there is a statement here where axial deformation are ignored, A is equal to 0. Where axial deformation are ignored, normally it will be given in the question. Okay, the statement meaning which means A is equivalent to 0, means that A will be neglected. A will be neglected. Axial deformation are ignored. A is equal to 0. Consider bending effect only. A is equal to 0. Consider the first, the primary mode of deformation. A is equal to 0. Okay, so actually in this formula, whenever A equal to 0, so all AE will be cancelled. AE cancel. AE will be cancelled. Okay, all AE will be cancelled. So we still have 6 by 6, but we don't have to consider AE, so we ignore axial effect. We ignore axial deformation. We consider only bending effect. We consider only the primary mode of deformation. So what we have actually in this formula is only, okay, EI will be constant. EI will be constant. So we only have 4 values in this matrix to be calculated. It is 12 over L cube. We get from here. Okay, and then we get 6 over L square. This one. And then we get 12 over L cube. Sini 12 over L cube, 12 over L cube, 6 over L square. Okay, repeating the same. Even though you can see that this is look complicated, okay, formula, but it will repeat the same value. Okay, 12 over L cube, 6 over L square, 6 over L square. This one also 12 divided by L cube, 6 divided by L square, and then 4 divided by L. 4 divided by L, it is 4 divided by L, and then we have 6 divided by L square. This is also 6 divided by L square. And we have another one. It is 2 divided by L. 2 divided by L. 2 divided by L. This is 4 values, 4 repeating value. So only these 4 values. So of course we have to calculate. We have to time with Cx and Cy. So all this is 12. If it is 12, it is 12 divided by L cube. If it is 6, it is 6 divided by L square. And then we have 2 over L, and we have 4 over L. So 4 values only in the table. In the matrix. 4 values only. Okay. Okay, go back to the question. So this will be the question. So we actually have to combine what we do in truss and beam. We combine into frame. So number one, the structure must have node number. A, B, C, D also accepted. Okay. Element number. So here we can label element as element 1, element 2, element 3. Element 1, element 2, element 3, we can label. So let's say we label AD as element number 1, BD as element number 2, CD as element number 3. So number 1, node number, make sure the frame has node number. Can be A, B, C, D. Number 2, we have to label element number. Number 3, we have to have, okay, arrow. And arrow is special because we can put arrow in any direction that we like. Doesn't matter. Okay, put in any direction that we like. Arrow is important in order to identify near and far and nodes, and to label K correctly. Because we have to label K according to near to far. Near XYZ, far XYZ. Okay, number 4. We have to have coordinate. Coordinate is important. Is very important in frame because we have to have CX and CY. We have to calculate CX and CY. So it is based on coordinate. Okay, coordinate. Okay, when we have frame like this, it is okay to choose any of these A, B, C, D as origin. Okay, any of A, B, C, D can be origin. But what is suggested by Hibler in the textbook is we can choose, okay, we can choose 1 point we label as origin. 1 point we label as origin, and by choosing the new origin, we will get all positive coordinate. You can do like this if you want. Okay, we can do like this if we want. So we label this as 0. Okay, this is origin. So at this point, the coordinate will be 0, 0. Coordinate will be 0, 0. So from this origin, then only we label A, B, C, D coordinate. Okay, so we label C as 5, 0. And then D will be 5, 5, 4. Okay, B will be 5, 8. 5, 8. and A will be 0, 4. 0, 4. Okay, so by choosing one point as origin like this, so the all A, B, C, D will have positive coordinate. Okay. Okay, lastly, what most important is degree of freedom. It is degree of freedom. We have to label degree of freedom. We have to label degree of freedom. We from number of nodes, we know that there are four nodes equal to 4 times 3, 12. 12 degree of freedom. So this degree of freedom ni, it is 12 combination of unknown reaction which is occur in constraint system, and unknown displacement occur in unconstrained system. Okay, it is a simple if we identify number of unknown reaction in the frame. Okay, it is simple like that. Identify number of unknown reaction means identify support. So from this diagram, we can see that there are 3 fixed support at A, at B, and at C. Means that there are nine unknown reaction. There are 9 unknown reaction. A is fixed, B is fixed, C is fixed. So there are 9 unknown reaction. Okay, it is 9 unknown reaction. Q is reaction. U is unknown. So it is 9 unknown reaction located in constraint system. This is what I mean. Constraint degree of freedom system. Constraint degree of freedom system. Because in constraint system there are no movement. Okay, because of the support. So since this has 9, so we will have remaining 3. So remaining 3 will be 3 unknown displacement. 3 unknown displacement located in unconstrained degree of freedom system. Okay, so total is 12. The total is 12. Okay, total is 12. 12. So this 12, we have to refer back to the diagram. Refer to the diagram. Identify number of unknown reaction first. Number of unknown reaction first, because number of unknown reaction, okay, we get by looking at the support. By looking at the support, so there are 3 fixed support. 3 fixed support. So 3 fixed support. So 3 times 3. So we get 9. We get 9 unknown reaction. So in 12 degree of freedom, 9 belong to unknown reaction. So remaining 3 will belong to unknown displacement. Unknown displacement. So unknown reaction are located in constraint degree of freedom system, and unknown displacement will be located in unconstrained system. However, for numbering, since unknown displacement will be the first output, unknown displacement will be the first output, and unknown reaction will be the second output. So that is why we should label from unconstrained system first, then only followed by constraint. So we must label start from unconstrained. start from unconstrained. D is unconstrained. D is unconstrained. So label X, Y, Z 1, 2, 3. Okay, in unconstrained. In unconstrained, so continue remaining 9. 3, 1, 2, 3, 4, 5, 6. 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. And 9, 10, 11, 12. So there are 12 degree of freedom. There are 12 degree of freedom. 12 degree of freedom. The question is, consider bending effect only, means A is equal to 0. EI is given as 200,000. Okay, question A, establish element stiffness matrices. Element stiffness matrices means K1, K2, and K3. And equivalent element nodal force vector in the global coordinate system. Yang ni Q1 naught, Q2 naught, Q3 naught. Q1 naught, Q2 naught, Q3 naught. Okay, small letter we use for element. Okay, and then when we combine, we get structure stiffness matrix, and we get equivalent nodal forces. Okay, and after that, the next question is we have to compute rotation. Compute rotation. Rotation means unknown. Rotation means unknown displacement. Unknown displacement. Okay, located in unconstrained system, it will be D3. It will be D3. Rotation. Rotates. So representing rotation means displacement in Z component. Displacement in Z component. So what we need to calculate is actually D3. Okay, this is rotation at D. Rotation at D. Okay, so we focus on A and B first. Okay, so okay, we start with element number 1. Element number 1. Okay, for element number 1. Okay, element 1. Remember, just now it is 12 divided by L cube. 12 divided by L cube is 12 divided by L cube is L is 5. L is 5. Okay, 12 divided by L cube is 12 divided by it is 0.096. This is 12 divided by L cube. And then 6 divided by L square, it is 6 divided by 0.24. Okay, and we have 4 divided by L, 0.8. And we have 2 divided by L, 0.4. 0.2 divided by 5, 0.4 lah. 0.4. Okay, CX and CY. CX and CY actually, it will be 5 minus 0 divided by 5. CX is 1, CY is 0. For element number 1, Cx will be 1, Cy will be 0 because it is a horizontal member. So we get like this. Okay, Cx and Cy. So we just need to substitute into the formula. Substitute into the formula. So for K1, for K1, it is 3EI. Don't forget this is 3EI. 3EI. So refer to the formula. Cy0, Cx1. Cy0, Cx. Okay, we just need to substitute into this. So Cy sini 0, ini pun jadi 0. Okay, mana yang ada value? Cx, Cy yang ni pun jadi 0. So this one also 0. Cy 0, this one also 0. This is Cy0. This is also Cy0, Cy0. Okay, so yang ni ada value lah Cx. Cx ada value, sini 0, sini 0. Yang ni ada value. Cx yang ni ada value. So the rest 0. So actually the value in the matrix like this. Okay, so yang ni I have set the formula. So A is equal to 0. So EI 3. I3, length is 5. Cx is 1. Cx is 1. Cy is equal to 0. So what we get is this. So this is the value. This is the K. So this is K1. So here, okay. So this is K1 EI. This is the matrix. Okay, this is the matrix. But don't forget to label. Label ni, okay, when we want to label, we have to label by looking at the arrow from near to far. So we will label the K1 as 789, 789, 1, 2, 3. Okay, 789, 1, 2, 3. So it is 7, 8, 9, 9. Bukan sini ya. 7, 7, 8, 8, 9, 1, 2, 3. Okay. 7, 8, 9, 1, 2, 3. Same goes to here. 7, 8, 9, 1, 2, 3. Okay, we label from near to far. At near, we have 7, 8, 9. At far, we have 1, 2, 3. We identify from the arrow. The arrow always move towards far end. The arrow is always move towards far end. So, near will be 7, 8, 9 ni lah. Okay. So, yang ni dia punya label. This is for K1. Okay. K2. Okay. For element number 2, we will have Cx, Cy. CX, CY, it is EI only. CX, CY is 0, 1. CX, CY is 0, 1. Okay, for element number 2, CX is 0, CY is 1. Okay, so the length is 4. Length is 4. So it is 12 over L cube, 6 over L square, 4 over L, and 2 over L. Okay, this is because you need to calculate it manually. Okay, it is 12 divided by 4 cube. So this one 0.1875. 6 divided by 0.375. 4 divided by 4, 1. 2 divided by 4, 0.5. So 4 values, this is the 4 values that we will put into the formula. Okay, I straight away put into this. Length is 4. CX 0, CY is 1. So this will be K2. This will be K2. Okay, this is K2. This is K1 EI. This is K2 EI. Okay, again, we have to label correctly. To label correctly, so looking back to element, to the diagram, from the arrow, okay, the label for K2 will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So label 1, 2, 3, 4, 5, 6. So this is the label. Okay, 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6. So this will be the label for K2. The label for K2. And then for element number 3. Element number 3. Okay, length is equal. EI also constant. Okay, CX and CY also same, 0 and 1. So actually we get the same value, except the labeling. Labeling for K3, will be 10, 11, 12, 1, 2, 3 because we base on the arrow. We based on the arrow, we label start from near. Near is 10, 11, 12, 1, 2, 3. 10, 11, 12, 1, 2, 3. So it is actually the same. So this will be K3, but we label as 10, 11, 12, 1, 2, 10, 11, 12, 1, 2, 3. Okay, label degree of freedom from near to far. Label degree of freedom from near to far. This is K3. Okay, so this is the answer for element stiffness matrices. Element stiffness matrices K1, K2, K3. So this is actually the answer. Okay, we continue to calculate equivalent element nodal force vector or equivalent element nodal forces. Okay, this we will use fixed end reaction to calculate. So equivalent element nodal force vector ni apa dia? We will distribute element yang mana ada loading on top of the member. Okay, we distribute it equivalently. That is why we call it as equivalent nodal forces, equivalent element for each element. Okay, because member cannot carry load. So if the member has loading on top of it, because in stiffness matrix method, remember we will calculate displacement, we will calculate forces at nodes. So by looking at this frame, element number 1 or member AD, element number 1 or member AD has UDL 50 kilonewton per meter. So this 50 kilonewton per meter, we have to distribute it equivalently. Okay, to node A and node B, node D. Node A and node D, we have to distribute it. For element number 2 and element number 3, since there is no horizontal force or UDL, which is subjected directly along the member or on the member, maybe at the center there is no value, there is no force, there is no forces. So means that Q2 naught, Q3 naught, all value will be 0. But we have Q1 naught value, which we get from 50 kilonewton per meter. We have to distribute it equivalently to node A and node D. Okay, so this one we have to refer to appendix page number 3. Appendix page number 3, so it will be this one. Okay, so simple formula, it is equal to fixed end moment. So the behavior, it is behavior because fixed end moment is behavior. But now we have to consider the vertical reaction as well, not only moment. Okay, so due to this, we will have moment acting in this direction, in these two direction, opposite direction because of the behavior. And we will have also the vertical reaction. Okay, at A and at B. So the vertical reaction, the vertical reaction due to W will be WL over 2, and moment, fixed end moment is WL squared over 12. Okay, over 12. So normally what I can suggest is, okay, we have to draw the free body diagram of element number 1 and put This is element number 1 near to far. Near to far. The DOF label for element number 1. For element number 1 is 1, 2, 3. 1, 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. Actually, label ni sama macam K. Okay, label ni sama macam K. So, what we will produce is, okay, Q naught, Q kecil, Q naught, okay, with 6 value. It must be written in matrix form. It must be written in matrix form, and we should compare with the formula. So this is W. Assume all fixed. This is 50. Length is 5 meter. Okay. So for this beam, the fixed end moment acting. Okay, in this direction is WL squared over 12. It is 50 times 5 squared over 12. 50 times 5 squared over 12. So we get 104.167. 104.167. And for the vertical reaction, it is WL over 2. WL over 2. It is 125, right? 125. Okay. So, it will be easier if we compare these two diagrams. We compare these two diagrams. We are producing Q kecil. It is Q naught equivalent element nodal forces, and this is for element number 1. So 1 naught. Okay, we will get 6 value which we label same as we label K1. For K1 we label as okay, 7, 8, 9, 1, 2, 3. 7, 8, 9, 1, 2, 3. Okay, we label Q not Q1 not. This is equivalent element nodal force. Okay, for element number 1. So Q naught is for equivalent nodal forces. Q kecil for element, Q capital for overall. Okay, combination. Okay, 1 is for element number 1. The label is 7, 8, 9, 1, 2, 3. 7, 8, 9, 1, 2, 3. So we compare these two diagrams. So at position number 7, compare these two diagrams. Okay, if there is no value, okay, we can find the value, so it will be 0. Okay, if the reaction is opposite condition, it will be negative. Same direction, it will be positive. Okay, so for Q1 naught at position number 7, what is the value? Position number 7, find the value in the second diagram in X direction, at near nodes. Is there any value that we can put? Compare. No. There is no value. Because this is beam, right? This is beam and we don't have X value. So 7 at position number 7, the value is 0. So next value. What is the value at position number 7? Number 8. What is the value at position number 8? What is the value? Position number 8.
125.
It is 125. Positive because it has same, for both diagram, when we compare the arrow, when the arrow have similar direction, same direction, so it will be positive. Positive. So it is positive 125. Okay, next position is position number 9. Position number 9, what is the value? Position number 9.
104.167.
Okay, it is 104.167. Positive or negative? Positive or negative? It is positive. Okay, it is positive. Positive because it has same moment direction. Same moment direction. Okay, next. Position number 1. What is the value? Position number 1.
0.
Okay, position number 1 is 0. Position number 2.
125.
It is 125. Position number 3. Position
Negative 104.
104.167. 104.167. Okay, so this is Q1 node. So we have Q2 node, which all value 0 because there is no loading on or along the member. Q2 node label same as K2. Q2 node label DOF same as K2, and Q3 node also 0. Okay, label same as K3. Label same as K3. So this is actually the answer. The answer for question number 1. Element global stiffness matrices K1, K2, K3, and equivalent element nodal force vector Q1 naught, Q2 naught, Q3 naught. Okay, that's the answer. Okay, so this is the answer. K1, K1, K2, K3, and Q1 naught, Q2 naught, Q3 naught. The answer for question A. For question A. Okay, move to question B. Move to question B. Compute the rotation. Compute the rotation at D. So rotation, we only have one rotation at D because A, B, and C are constrained. Rotation, okay, rotation will only appear in unconstrained system. D lah, because D is unconstrained. D is unconstrained. So we have learned previously, we have to read the label, the physical meaning of the label. So in unconstrained, we will have D1, D2, D3. And this is displacement, D1 displacement in X component, D1 displacement in X component. It represents horizontal deflection at D. This is horizontal deflection at D. Okay, D2. What is D2? What is the physical meaning of D2? Okay, what is the physical meaning of D2? Okay, 2 is vertical In vertical component, it is vertical. Vertical deflection at D. Okay. And what is D3? In Z component, it is a rotation. Rotational displacement. Rotation at D. And rotation at D is theta D. So, even though the question only asks us to calculate rotation, we still have to calculate all these three. Because they one set. How to get this? We will get this from stiffness equation. And for this question, actually, we don't need to establish in full 12 by 12 matrix. No need. No need for us to establish structure stiffness matrix in total 12 by 12 because, okay, there's no sentence in the question asking you to do that. Okay, so we directly focus on the second question, second part. We have to compute rotation. So we know that we have to use the stiffness equation. For frame, we use Q is equal to KD plus Q naught. KD plus Q naught. Even though in total we have 12. We have 12 degree of freedom. And from the support, since there are 9 degree of freedom in constraint system, means D at all fixed support, all displacement will be 0. So it means that in order to calculate rotation at unconstrained system, in order to calculate displacement, 3 displacement D1, D2, D3 in unconstrained system, we just need to have the stiffness equation corresponding to unconstrained degree of freedom system only. Means that we have to get stiffness matrix only on only 3 by 3 matrix, not 12 by 12. Because that is why at the beginning of analysis we do this step. Okay, we have to identify how many degree of freedom belong to constraint system and how many degree of freedom belong to unconstrained system. Okay, because whenever we want to solve unknown displacement without support settlement, it is just analyzing stiffness equation corresponding to unconstrained system only. So what we will get is Q is equal to KD plus Q naught. So what we will get is only this. It is 3 by 3. D1, D2, D3 plus Q naught until position 3 only. 1, 2, 3 only. Okay, so we have to fill in this equation with value. Fill in this equation with value in matrix form. Then when we solve this, we will get D1, D2, and D3. We can solve using calculator directly by using 3 simultaneous equation with 3 unknown, X, Y, and Z, representing D1, D2, and D3. Okay, so we will calculate K first. K for position 1, 1 until 3, 3. So we refer back to this. So we will produce K. In EI. So what we want is only 1, 2, and 3. 1, 2, and 3 only. Okay, 1, 2, and 3 only. So this is only what we want because we have 3 degrees of freedom in unconstrained system. We have 3 degrees of freedom in unconstrained system. Okay. Okay, 1, 1. 1, 1. Okay, find the value from K1. From K1 we have 0. From K2 we have 0.1875. K3 we have 0.1875. 1, 1. So it is 0.375. 0.375. Okay, next position is 1, 2. Next position is 1, 2. 1, 2. 0. Okay, 1, 2 in K2. 0. 1, 2 in K3. 1, 2 in K3 is also 0. Okay, next. Okay, position 1, 3. Position 1, 3. Okay, position 1, 3. We have 1, 3 in K1. 1, 3 in K1 is 0. 1, 3 in K2. 1, 3 in K2 is negative 0.375 plus 1, 3. This is 3, 3, 1, 3, 1, 3, 0.375. 1, 3, or 3, 1. Okay, it is 0 as well. So this is symmetry matrix. So K ni, because it is, we will write in matrix form, so it will have symmetry matrix. Okay, 2, 2. 2, 2 we get from K1. K1, 2, 2 is 0.288. 0.288 plus 2, 2 in K2 equal to 0 plus 2, 2 in K3 is also equal to 0. So it is 0.288. Next is 2, 3. Next is 2, 3. 2, 3 in K1. 2, 3. Negative 0.72. Negative 0.72 plus 2, 3. 0 plus 2, 3. 2, 3. And for 3, 3. 3, 3 in K1. 2.4. 3, 3 in K2. 1. 3, 3 in K3. Also 1. Okay, so this is the matrix. This is the matrix. Okay, this is the matrix. Okay, so this is the matrix. So times with D. Just continue here. This is D D1, D1, D2, D3. This is EI. Okay, plus with Q naught. Plus with Q naught. Q naught 1, 2, 3. Q naught 1, 2, 3. Q naught 1, 2, 3 is this. Q naught 1, 2, 3. Q naught 1, 2, 3 is 0, 1, 2, 5. 0, 1, 2, 5. And negative. Negative 104. 167. Okay. And this one is 0, 0, 0 kan. So ni 0, 0, 0. All 0 for Q naught because there is no nodal forces. There is no nodal forces. Okay, so we combine. So what we get is we have to bring this. Okay, silap. Okay, here. Okay, Q naught bring to the other side. Q naught bring to the other side. So we use 3 simultaneous equation. We get it is equation. We have 3 unknown. Okay, 3 unknown. So A1 will be 0.375 and then 0. C1 also 0. D1 is also 0. It is 0, 0 minus 0. Okay, next value is 0. Then 0.288. 0.288. Then negative 0.72. And then it is 0 minus 125. 0 minus 125, it is negative 125. A3 is 0. B3 is negative 0.72. C3 is 4.4. D3 is 0 plus 104.167. It is positive 104.167. So D1 is 0. D2 is negative 634 per EI. And D3, which is rotation, equal to negative 80.128 over EI radian. Okay, so from the simultaneous equation, from simultaneous equation, we get D3, which is equal to rotation at D, at joint D. It is D3. It is D3, which is equal to rotation at D equal to negative 80.128 divided by EI radian. Okay, if EI is given, then we can divide by EI. Okay, if not, we can leave the answer in EI, in terms of EI, like this. Okay, we solve simultaneous equation with we solve stiffness equation by using 3 simultaneous equation. So what we want is only D3, because D3 is actually rotation at position D. Okay, so we get negative 80.128. Negative 80.128 radian. Okay, so we answer question B. Okay, so from D1, D2, D3, if the question asks us to calculate reaction at the support, normally kalau we have 9 unknown reaction. Okay, 9 unknown reaction, basically you tak kena pun calculate semua 9 tu, because you have to remember dalam final assessment ni nak tengok your understanding. Because kalau you boleh calculate for example reaction at joint B, reaction at fixed B, fixed end B, then it will represent the same when you calculate reaction at A, reaction at C. So basically kalau reaction pun ditanya, so dia akan tanya you at certain position only, because we want to see your understanding. Okay, so the last question ni is just to cater level of difficulty, higher level. So that is why you see this question. So question for representing difficulty level ni, dia akan always different every semester. Okay, dia tak akan repeat the same thing lah. Okay. Yang the same thing tu yang basic procedure tu lah, basic procedure when we analyze frame, for example like this frame, number one macam yang saya tunjuk tadi, number one, make sure diagram tu kena complete dengan all labeling. Okay, note number, element number, arrow, we must put the arrow, and then coordinate ni nak, because kita nak cari CX and CY. That is why we have to put coordinate. Macam this case, dia quite simple because in this frame, dia cuma ada horizontal member and vertical member. Tapi kalau ada incline member, memang you have to have CX and CY. Baru dapat CX and CY tu. Kalau without coordinate, kita akan dapat lah. Tapi kalau horizontal member, vertical member yang ni, kita dah tahu dah. Dia either CX0, CX1, CY0, or kalau vertical member dia akan jadi CX0, CY1. Okay, so yang tu dah boleh skip CX, CY. Tapi dia akan depend on arrow lah. Kalau arrow terbalik, dia akan jadi negative 1. Okay, so completekan yang ni. Lepas tu, so kalau soalan tu frame, you must read the question carefully. Because normally, frame kalau keluar dekat exam, cerita pasal exam dulu-dulu, ramai student dia tengok soalan dia terus buat. Okey, dia terus buat K1, K2, K3. Lepas tu dia pergi buat 12 by 12 matrix, which soalan langsung tak minta, and then dia akan start dekat situ. So that's why kalau based on previous experience, memang student tak boleh buat sebab dia buat benda yang tak diminta dalam soalan, dan memang wasting so many time. And lastly, tak sempat siap. Okay, so read the question carefully. Just give a according to the question. So question asks, in the question asks us to calculate K1, K2, K3. So just give K1, K2, K3. No need to give structure stiffness matrix in full, 12 by 12. Because what we want to analyze unknown displacement is only corresponding to unconstrained. Normally unconstrained ni kita dah set either 2 degree of freedom or 3 degree of freedom. Kalau 4 degree of freedom tu normally soalan tu memang sampai equation only. We don't need to solve that. Okay, we don't need to solve that. Okay, so yang ni K1, K2, K3 and in frame analysis as well as beam. Beam dengan frame ni dia ada similarity dekat equivalent nodal forces. Beam dengan frame. Beam dengan frame. Cuma dekat beam, we don't have to consider X component. So ada juga Q1 not, Q2 not, Q3 not in beam. Especially bila ada UDL and bila ada point load which subjected on member. Bukan hujung, because hujung dia jadi nodal force. Kalau vertical force tu subjected at hujung, at nodes. So yang tu dia tak jadi yang ni, dia akan jadi Q, nodal forces. Q naught ni yang mana loading tu dia jatuh atas member. Dia jatuh atas member, you have to distribute it equivalently. Okay, sebab member cannot carry load, we have to distribute. So the easiest way to distribute loading which is subjected on member, okay, is like this. Okay, it's like this. We call it as equivalent element nodal forces. Okay, draw diagram like what I have shown to you just now, two diagram, and then we compare. And then baru kita bawa Q naught ni kita bawa sebelah sini, baru kita total. Kalau you combine without calculating Q naught ni, equivalent element nodal forces, ramai yang selalu silap. Okay, ramai yang selalu silap. Kalau you terus guna Q is equal to KD, so Q naught calculate using formula dalam diagram, terus letak dalam one main diagram, ramai yang selalu silap sign. And then jawapan memang akhirnya salah. Okay, so I will suggest you to analyze beam dengan frame considering Q naught as equivalent element nodal forces. Calculate it separately. Do not combine dengan nodal forces. Nodal forces remain as nodal forces. You just need to read whatever forces that is subjected directly at nodes, yang tu jadi nodal forces. So mana-mana elemen yang ada loading on top of the member, yang tu jadi Q naught, equivalent nodal forces. So calculate separately and then kita substitute into the formula. Okay, substitute into the formula. Q is equal to KD plus Q naught, and then kita akan dapat like what we have analysed tonight. Okay, so this is frame. Basically frame ni, kalau saya tak explain pun you should be able to do, because frame ni dia 75% macam beam analysis. Okay, 75% macam beam analysis. Truss about 25% only lah because of C8, because of coordinate. Tapi Q tu dia lebih mirip pada beam. Okay, so basically stiffness methods ni I have cover 90%. Ada lagi satu yang saya belum cover. We will use the same equation, Q is equal to KD, tapi Q naught dalam truss not belong to external loading. Q naught dalam truss is not belong to external loading. Q naught dalam truss belong to effect like temperature changes and fabrication error. So frame ni, please try to understand it very well, because assignment yang saya nak bagi end of this week, okay, kalau you faham what I have explained to you tonight, I believe you can do the assignment. One question only. It is just like normal exercise. Okay, one question. Follow the procedure like what I have shown to you tonight. So you will get full mark. Okay, for 10%. For 10%. So yang you have to focus is another 60%, which come from final exam lah. Final exam. Okay, a final assessment. Final assessment, even though dia masih lagi online, tapi dia follow final exam. Means 4 question in 3 hours. So yang tu yang you have to focus a lot. Okay, for session tomorrow, another 1 hour session, I will cover truss yang ada effect of temperature and fabrication error before we close lecture for this semester. Okay, so dah 10:20. Do you have any question before we end this session? Do you have question?
No, we don't.
No question. Okay. So assignment tu saya tak nak bagi masa sampai seminggu 2 minggu, tak nak. So just baca message yang saya tulis dekat Teams. Dekat Teams tu saya akan bagi soalan 24 hour before 24 hours. Lepas tu saya nak you buat within 1 hour je. Dia bukan test, dia assignment. That's why saya bagi soalan awal. Okay, you dah boleh prepare apa yang patut. Okay, nanti you buat assignment, because assignment pun dia ada time frame. Dia bukan you boleh buat dalam masa 20 dalam masa 48 jam ke. Tak perlu pun, you buat 1 jam dah boleh siap. So nanti you hantar hari Jumaat ada test ke?
Tak ada, madam.
Okay, 1 jam tu boleh siap lah.
Tak
Saya
ada.
bagi soalan 24 hours before. With two unknown. Unknown tu one from loading, one from air lah. So pandai-pandai you plan apa yang patut before using the diagram given tu before yang hari Jumaat tu kan. Okay, and then bila sampai Jumaat tu, okay, saya akan bagi two unknown value tu, then you completekan and submit after 1 hour. Okay, so that will be your 10% assignment. Okay, 10% assignment. So so stiffness matrix method, we have 3 types. I have covered 3 types. Beam, truss and frame. So in final assessment, there will be 2 questions come from stiffness method. 2 questions come from stiffness method. Okay, one I cover under assignment, and there will be another 2 questions in final assessment. Okay, and stiffness method ni is actually the easiest method where you can score full mark actually from stiffness method. Okay, dia tak sama macam flexibility. Flexibility yang you have to find the moment equation. Dia tak sama macam tu. Yang tu ramai yang buat mistake, ramai yang careless. Ramai yang tak boleh buat juga truss, member forces in truss using flexibility method. So ramai yang sangkut kat situ. So you boleh fokus 50 out of 100 marks final assessment from stiffness method. Because stiffness method ni is very straightforward question. Procedure dia pun repeat the same process. So you have to clear everything. Every procedure ni kena clear, labeling kena clear, degree of freedom kena clear. Degree of freedom ni, direction yang saya draw dalam diagram, dalam setiap solution tu, that is the sign convention that you have to use every time you analyze beam frame truss using stiffness method. You cannot change the direction. You cannot change the direction. You tak boleh pergi terbalikkan dia punya arrow tu, tak boleh. You tak boleh letak dia punya Z component tu clockwise, tak boleh. You must follow sign convention. Sign convention ni, you must follow this sign convention sebab formula yang kita pakai, okay, formula derive, okay, formula ni we derive, okay, we derive. So this formula is derived based on sign convention shown. So sign convention dia macam ni. That is why we get macam ni, ada sign negatif, positif macam yang kita nampak ni lah. Yang kita nampak ni. That is why sign convention ni, jangan change sign convention. Jangan pergi terbalikkan dia punya sign convention. Ada yang buat. Selalu setiap semester akan ada yang pergi tukar dia punya sign convention. You tukar dia punya sign convention, memang akan habis. Okay? So you cannot change sign convention because they relate dengan formula yang kita pakai to calculate element stiffness matrices. Sama juga dengan beam. Normally yang Z ni lah, Z komponen ramai yang suka terbalikkan. Tapi ada juga yang buat Y dengan X tu dipergi tukar arah lain. So jangan buat yang tu. You mesti follow sign convention given. Okay, because the formula is derived based on the sign convention. Okay, sama juga dengan frame ni. Okay, X, Y, kanan, atas dengan counterclockwise. You must follow the sign convention. Okay, so fokus betul-betul stiffness matrix method, you insyaAllah confirm boleh pass. Okay, tapi kalau nak score, make sure you put, okay, you put additional effort. Okay, because tak ada alasan untuk tak dapat score pun, sebab actually flexibility method, moment distribution method, flexibility method tu pun macam revision juga, sebab you dah biasa dengan moment equation, you dah biasa dengan virtual work method, so it should be no problem pun actually. And then moment distribution method, for those who come from diploma, you dah belajar dah before this. Masa diploma dah pernah jumpa pun moment distribution method. So actually tak ada alasan pun untuk you fail this course. So do necessary action. Okay, so that's all for tonight. So kita jumpa esok insyaAllah 1 hour. So I will cover thrust, the effect of temperature changes and fabrication error in thrust, just a bit only because it will be Q0 in thrust. Okay, so thank you very much. Thank you for joining. So don't forget to complete your attendance in the future. So we will meet again insyaAllah tomorrow. Okay, so thank you. We meet again tomorrow. Assalamualaikum warahmatullahi wabarakatuh.